What's up, my fabulous chemistry minions? Video number 4, modeling ionic bonding. Basically, we're going to draw them and we're going to use this ABCD method. How do we draw ionic bonds or molecules that are ionically bonded, right? So, how we draw them on paper. First, ABCD method is an acronym for atoms, brackets, charges, dots. Atoms are the symbols. Brackets are literally brackets around them. Charges, upper right-hand corner, which is this side for you, right? Plus or minus 1. And then dots are the electrons. We learned how to do Lewis dots in the past. This is basically a Lewis dot for an ionic. So let's check this out. I would, because I'm going to do this slowly, you might want to watch this one time before you draw the stuff out, okay? So just to save yourself some space. So first example, LiCl, lithium chloride. We'll learn to name that in the next video. First, I start by drawing the atoms. So I got Li, I got Cl. That's the A piece, okay? Then I need brackets, okay? Brackets say, my electrons, you cannot have them, because we learned that in ionic, we have complete transfer of electrons. Then charges, Li makes a +1, Cl makes a -1. Those are my charges. So now I got A, B, C all set. Now all I need is dots, and the valence electrons are always going to be around the non-metal because that's who gains electrons. So notice I drew them black. Those are the 7 valence electrons that chlorine has normally. And then the red one is the one that lithium lost to come on over. Now chlorine's octet is full. We don't draw dots necessarily around the metals because he lost his valence electron, so I don't need to show his valence shell anymore. We don't need to show the underneath piece, but if I look at lithium, it's 2-1, and he wouldn't have a full octet anymore. Now he's down to that duet. But he's got a plus charge. Notice my +1 and my -1 cancel out. This is your first example of how to draw a Lewis dot. Good? I think we got another one. Calcium fluoride, CaF2. Notice I have a metal and a non-metal again. It's one of the things I need for ionics. And let me start. I got an F, a Ca, and an F. So this is the first time we've seen the subscript, the 2 after the F. The way it works in chemistry is the subscript tells me how many come before it. So it goes F2, so 2 Fs, 1 Ca. So I need to draw F twice. I draw it on either side, doesn't really make a difference. Now I need my brackets. I have my atoms, I need my brackets. Notice I'm leaving enough space in my brackets for the charges and for the dots, and more around for fluorine. So you might want to wait till it's all drawn to put it in there. I will never ding you if you put the charge on the outside of the bracket. Just letting you know that. The electrons need to be inside. The charge can be inside or outside, but I prefer that you're consistent. So I put them all on the inside. All right, and then fluorines are the nonmetals, so they're going to have their electrons. Now, calcium loses 2, loses 1 to one fluorine, 1 to the other fluorine, +2, and 2 negative ones cancel out to be 0. Good? That was a lot. All right, next page. All right, all group 1 ions form +1 ions, and we saw that. So Li, Na, K. Good, I went fast, but you know which ones they are. Li, Na, K, believe it or not, rubidium and cesium also. Group 2 metals will always form +2 ions. We don't have to guess about this. Metals just lose their ions, and there's only one choice for you in the reference table when you look at the oxidation state. So beryllium, magnesium, calcium all form +2 ions. Okay. Group 16 nonmetals all form -2 ions. So oxygen's always going to be a -2 ion. Notice I put the 2 in red. Those are the 2 that scooped up from somebody else. If you took those red ones apart, that would be the Lewis dot that I taught you how to draw during the atoms unit. Okay. Now it's an ion, so I have the charge in the brackets to let me know it's an ion. Sulfur right below oxygen, also same thing. The difference is S instead of O. Okay. Group 17 forms -1 ion, so they're only going to have 1 red dot. So fluorine has 7 valence electrons, gets 1 more. Same with chlorine, same with bromine. Okay, I know I went fast, but you're going to be able to get through that pretty quick. I want to move on to the next piece and put more together so you can feel for how we do it. Transition metals form multiple ions. Polyatomic ions tell me where the charge is using table E. Two things we're going to figure out here. Ready? Check it, watch. So copper +1 or copper +2. That's where the potential problem is going to come in. It could be copper +1. It could be a copper +2. Next slide, I'm going to teach you how to figure out which one to use. There's another one, though, about iron. Could be +2, or iron could be +3. Notice there's multiple choices on a lot of the different transition metals. So we say the transition metals need a middle name when we name them. So we got to let you know what charge it is. Okay. Polyatomic ions are straight up right off the chart. So PO4 is a -3 every time, never changes. All right, SO4 is a -2 every time, never changes. Notice how I wrote that. I don't need to put in all the dots on a polyatomic. I can just write it out straight with its charge and we're all set. Okay. Same with CO3. CO3 is carbonate. Carbonate's always got a -2 charge. Okay. And in the reference table, it says 2-. Let's not get hung up on that. It's really a -2 charge. That's how I expect you to write. So now we need to put these things together and figure out their formula. So I see a Ba with a +2. So let me write Ba with a +2. There's my bracket. And I got an iodine with a -1. So that's iodine with a -1. My dots 1, 2, 3, 4, 5, 6, 7. Iodine is a group 17 metal. And he's a -1. So does my -1 and my +2 cancel out? No, they do not. So barium's supposed to lose 2, and so I need another iodine. 1, 2, 3, 4, 5, 6, 7. Another iodine with a -1 charge, and now -1 and -1 is -2. -2 and a +2 is 0. Now we've negated, and now I can figure out my formula. I have Ba, there's only one of them. Then I have iodine, and there's 2 of them. So it's an I with a little subscript 2. Okay, good. Let's keep going. I got K with an F. So I have K as my metal. I'm going to draw the metal first. It's a +1, and I don't need any dots on my metal. Then I have fluorine as a -1. Fluorine's a -1. Fluorine is a group 17, so he's got 7 valence electrons. And he gets 1 from potassium. And that makes him happy. And so I'm set. I got a +1, I got a -1. So that is, we're good. That's just K, F. It's got to be 2 capital letters to show me that there's 2 different elements. Okay, getting the hang of this? I hope so. Ca with a +2 and O with a -2. So first draw the metal. I got a Ca with a +2. Give me my brackets. I don't need to put electrons on that. Then I got my O. O is 1, 2, 3, 4, 5, 6. But he's a -2 charge. So I get that -2 by picking up 2 electrons from calcium. And here, this is a good one. Ready? The +2 and the -2 go ahead and cancel each other right out. So I'm good. It's just Ca with an O. Cs and a -2. Cs with a +1 and O2 with a -2. So I have Cs in the middle with a +1. Then I have O with a -2. O, 1, 2, 3, 4, 5, 6 valence electrons. He gets 2, 1 from 1 cesium that's here, and oh, he needs another one. Uh-oh, so we don't have enough cesiums. So he's a -2. So -2 and +1 do not equal out, so I need another metal. I need another Cs +1 in this case. Now they cancel out, so I have 2 CS's. Always draw the metal first. CS2O is my chemical formula. I have 2 CS's and 1 O. Good. All right, Na+1 and CS -2. I see that I'm going to need 2 NAs right off the bat. Notice I just learned from the last one that +1 -2, +1 -2. I need 2 +1, so I'm going to go ahead and draw Na twice. So each Na gives up one electron, but O needs two. 1, 2, 3, 4, 5, 6. Like the periodic table tells me, get one from one Na, one from another, and now I am an O with a -2 charge. And so the formula for this now becomes Na with a +2 and one O. And that should be about it for this video. Yeah. See you guys in class tomorrow.